Hello everyone, and welcome to this video on gravitational microlensing. Gravitational microlensing is a method that's used to find exoplanets. Of all the methods that are used to find exoplanets, this one finds one of the fewest amount of exoplanets, and that is because the conditions required to find the exoplanets are very rare amongst stars and planets um, in our galaxy. So I'm going to start with this definition of a of gravitational microlensing, and then we'll work through what exactly it means. So the gravitational microlensing method works like this. When a foreground star transits exactly through the center of a background star, the gravity from the foreground star will bend the starlight like a lens. The lensed light is magnified, and the background star appears to briefly brighten. If the foreground star has an orbiting planet that is also aligned, the background star will brighten twice. All right, so what does that mean? All right, so I'm going to switch my cameras here so that you can see um, something that I'm going to be drawing for you. And I want to stop screen sharing so you can see what I will be drawing. All right, so what I'm going to be drawing is the alignment of these objects. So we're going to put the Earth down here. I'm going to put an E there for Earth. All right, and that's where the observer is. That's where we are. So, and we are we're looking at a star in the distance. Here's a star in the distance. That's the background star. And then that's not the star that has the planet. The star that has the planet is between us and the background star. So it is moving in this direction. So, and the planet, or the star, the bigger object's the star, and the smaller object's the planet. So what happens is when the planet moves directly between the Earth and the background star, this planet acts like a lens and causes the light to be lensed. And what that does is that makes this star back here brighten. Now, when the planet moves away from this position, the star gets dimmer again. So, so then we have our star that the planet is orbiting. It's also moving in this direction, and eventually it will get here in this position. And when it gets there in that position, it acts like a lens. It acts like a lens again, and it causes this star in the background to get brighter again. And then when they move off, the star gets dim again. That's the gravitational microlensing method. The star that has the planet acts like a lens and causes another star in the background to get brighter. And when that star in the background gets brighter, that tells scientists that there is a planet around that star. Even weirder is sometimes the astronomers don't even see this star. It could be a very, very dim star, and it might cause the background star to get brighter. And scientists may not even see that star at all and its planet. So what happens on the data they get? What kind of data do they get? Well, they get the data in the form of a graph. So when the star when the planet was out here in this position, all they were seeing was the brightness of this star. Okay. And then when the planet got in that center point, they saw a blip. And then when the star got to this point, they saw a bigger blip in their graph. So the first item to reach that position where it can be a lens is right here. This is the planet. And then the second object that got there into the correct position to be a lens was the star. Okay, so the graph, you might think the graph is a little backwards because here your star is on this side and your planet is to the right of it. But on the graph, the planet appears first because the objects were moving in this direction. So the planet goes into the lensed position here first. So it appears on the graph first. The star goes into this position second. So it appears on the graph second. All right, so that's the gravitational microlensing method. Hope that little demonstration that I did should help you with the questions in the lab. I'm going to, what am I going to do here? I need to screen share again. And let's go back to this. So this diagram is an illustration of what I just showed you. So here, this is the observers down here below this. There's our star that was magnified. There's the image, the blip that's caused by this star. And then if the star has a planet, there's our second blip. Because when the planet moved into that position, there's our second blip in that case. So this demonstration on this slide is opposite the demonstration I did. So the one that I did had the planet in front of the star. This one has the planet after the star. All right, so if we go on, here's a little animation that shows what the brightening of this background star might look like. So there's a blip, that was a planet, and that's another planet, and that's the star. The width of the blips and the peaks gives them information about the mass of the object that's in between the two. The height isn't super accurate because the height of it might be more from the background star itself than the object that's causing the lensing. So it's the width of the blips and the peaks that that have more to do with finding the planet. Okay, so the pros. This method is sensitive enough to detect terrestrial planets. So we can find Earth-sized planets with this method. Cons are that the chances of a planet microlensing are very rare. To this point, 19 exoplanets have been found using the gravitational microlensing method, but thousands of planets have been found using the transit method that we just went over. And extremely sensitive instruments need to be used to detect this brightening effect. All right, guys, that's it for this video. Thank you for joining me, and I hope you have a good day.